Okay, welcome everybody to this version of Wednesday workshops. We try and bring you industry professionals talking about hot topics. And today we have Ron Eck, who is a mentor of mine at the National LTAP Association. But aside from that, he's also Professor Emeritus and PE and just very knowledgeable. And he's here to talk to us today about perpendicular curb ramp inspections. So without further ado, Ron, I will hand it over to you.
Thank you, Heather. Good afternoon, everyone. Bear with me a few seconds here while I share my screen. Let's see. Let me try again here. Yeah, this is not looking the same either, Heather. Let's see. In fact, I'm not seeing my screen. I'm just seeing my actual screen that you all are seeing.
Okay.
I'm not
Do
seeing my
you
desktop.
want to
Maybe
email
now.
me?
Pardon?
Because you could email me your document and I could share it.
Let's see. Huh.
Let me see.
I'm afraid it's going to be too big to email.
Okay. If I put the meeting invite in the chat, do you want to try and jump out and jump back in? See if you get the regular platform.
Yeah, I hope I can get back in. Sorry about this.
That's okay. Here you go. So just copy it from the chat. I just copied it with share meeting link. So hopefully that works out for you better.
Okay. Okay, let's see here.
Zoom the recording and we're good to go. So thanks for bearing with us, everybody. And Ron, I will again hand it over to you.
Okay, thanks, Heather. Hopefully everybody can see that. And
Yes.
again, I apologize as well for that delay, but we're going to be talking about inspecting curb ramps today. I'm Ron Eck, director of the West Virginia LTAP program, as Heather said. My email address is there. Feel free to contact me after the session if questions or concerns come up, or if you'd like a PDF copy of the presentation. I'm glad to share that. Here's our agenda today. Normally I do a 90-minute session on inspecting curb ramps. For the format here for the Wednesday sessions, I've abbreviated a bit. So we're just going to look at perpendicular curb ramps, which is probably the most common type of curb ramp. But we're going to do a brief background, look briefly at terminology and definitions, some of the tools that you need. Then we'll look at the requirements for perpendicular ramps, and we'll then look at some key curb ramp issues. And we'll wrap up by looking at top 10 curb ramp mistakes. Just some disclaimers or notes to start. I've prepared this session for a general audience, as the slide says, based on the Public Rights-of-Way Accessibility Guidelines, PROAG. I realize some agencies go above and beyond PROAG, so be sure to follow the relevant criteria for your jurisdiction. Also, the session's not meant to provide examples or illustrations of every field configuration or every ADA criteria. The engineers, contractors, and inspectors are still responsible for understanding and complying with all local, state, and federal equal access laws, including ADA. The photos I show in terms of how to and where to make the measurements are intended to show where to measure and the orientation of the level. They're not meant to show how many measurements to take, since this is going to vary from agency to agency. If your agency doesn't have a policy, my suggestion is that for a 5-foot wide by 5-foot long curb ramp, take at least 2 measurements of the landing running slope and the cross slope, and 3 of the ramp grade and the ramp cross slope. If the ramp is wider and or longer, add an additional row of measurements for each additional 2 feet of width and or length. Why is inspection so important? Well, I think there's 2 reasons. One is, of course, it's the law. The Americans with Disabilities Act says we have to provide accessible facilities, and the Department of Justice and the courts, through their rulings, are telling us that curb ramps are the basic element of accessibility. We need to make sure we have compliant curb. But to me, even a more important reason why this is so important is to accommodate users and to make our facilities accessible, mainly for the mobility impaired, people in wheelchairs or using canes or crutches or walkers. Also for the visually impaired. There's 2 categories here. Those who are blind, who may use a service animal, or more commonly, they'll use what's called the long cane or the white cane. But there's also a category of the visually impaired, those who suffer from low vision, who their vision is very poor. For example, they could never qualify for a driver's license, even with corrected vision. And so they rely on color contrast and textures to be able to navigate in the built environment. And the other thing about that category of individuals is they typically do not use a cane. This just shows really a small fraction of the various users that experience the issues that I just talked about. And each of these, of course, has different mobility needs in terms of being able to navigate in the built environment. Look at a few terms before we get into this. When I talk about grade, it refers to the finished grade, not of the string line or the forms or the wet concrete. And remember, there's no allowance for construction tolerance. We'll talk about that. Curb ramp, of course, is a ramp that cuts through or is built up to the curb to basically accomplish a change in elevation at the face of the curb, to allow those with mobility impairments to move between the sidewalk and the street. There's 2 types of curb ramps. There's perpendicular ramps and parallel ramps, and then we can also have a combination of parallel and perpendicular. But as I indicated, our interest today, our focus in this brief webinar is going to be on the perpendicular ramps like you see on the left side of the image. Cross slope refers to the grade that's at right angles to the direction of pedestrian travel, and so the level that you see in this photograph would be measuring the cross slope. And cross slope is critical because if the cross slope is steeper than 2%, the wheelchair user will find that the chair pulls to the right or the left depending on the direction of the cross slope. And in order to keep a straight line, it takes a lot more energy on a sloping surface than it does on a level surface. And when I say level in this session, I mean 2% cross slope or less. Detectable warning surfaces, DWS, or truncated domes. These appear typically at the base of curb ramps where the curb is missing, and they are a warning mechanism for the visually impaired. As you see here, a blind pedestrian is taught to detect this surface with the cane. I mentioned a few minutes ago that low vision pedestrians do not use a cane. So this surface was also designed to be detectable underfoot, meaning when a person's shoe or footwear steps down on that surface, they're able to detect it. And it is a warning mechanism. It has nothing to do with wayfinding or directionality. It's strictly a warning mechanism. And when the visually impaired encounter this, they are taught in orientation and mobility training to stop and check out the situation, their surroundings, before they proceed, because it means they're going to cross a vehicular pathway. So the way they would check things out is through their hearing. They listen for the sounds of approaching vehicular traffic, or if it's a signalized intersection with the APS, with the audible tones, they would listen for that as well. Flares. This is the gradual widening of the side of a curb ramp where the ramp is within a pedestrian circulation path, where that is where pedestrians are likely. The maximum slope of the flare is 10%, and that's measured parallel to the curb. And interestingly, these flares are here really strictly for the safety of able-bodied pedestrians. They're not part of the pedestrian access route. Pedestrian access route is the continuous, unobstructed path of travel provided for pedestrians with disabilities within or coinciding with a pedestrian circulation path. And here we see an image. Let me get my everybody can see that. Notice the yellow area is the pedestrian access route. This complies with the requirements of PROAG in terms of cross slope, surface, and width, and so forth. But notice that the actual circulation path where pedestrians might walk, able-bodied and disabled, would extend from the back of curb here where the cars are parked all the way to the storefronts. So in this case, the PAR is situated within the pedestrian circulation path, but they could also coincide. They could be the same. Running slope or grade is the grade or slope parallel to the direction of pedestrian travel. And in this photo, it looks like we have here on the left, probably an inspector on this job, and he's facing kind of toward the right. If he were to start walking down this grade or slope, we would say he would be descending that grade or descending that slope. Turning space. This is the area where someone in a wheelchair or using a walker or crutches, this is where they make their turning maneuvers, and it should be level, meaning 2% cross slope or less. If no turning takes place, for example, if someone in a wheelchair came up the ramp and was proceeding into the photograph here in the background, just going straight ahead, in that case, for them, it would be a landing. They're not actually making a turn on that, in that space. Not part of this session, but I did want to emphasize that if you're constructing new ramps, or when you're constructing new ramps, make sure that the temporary traffic control zone is compliant and that you comply with both PROAG and Part 6 of the Manual on Uniform Traffic Control Devices in terms of accessible and detectable temporary traffic control zones. And this zone that you see in the image here is not. There's no alternate pedestrian access route around that ramp construction area. Be sure you have the necessary tools. We'll talk in a second about digital levels, but I recommend having an engineer's metal measuring tape that can measure in tenths or hundredths of a foot. Some sort of writing or recording tool. It could be a clipboard and paper forms, or it could be a tablet or mobile device that with an app on it that you record your measurements that way. Either one is fine, but just make sure you have the appropriate tools when you're out there on the job. And then I recommend temporary pavement markers. It could be chalk or keel or something like that in case you need to make temporary marks on a surface. I recommend having actually two levels, a 24-inch or 2-foot level and the 6-inch level. 6-inch is for measuring slopes, as I'll show you, say on portions of a curb ramp or the gutter pan, which can't accommodate a 24-inch level. But the 24-inch level is typically recommended because that's the wheelbase of a typical manual wheelchair. Just as a note or reminder, make sure when you're making measurements that the level is set for the percentage measurements and you're not reading degrees, accidentally. So make sure it's set to the proper units. Measure your forms and then measure post-construction again. And now let's look, with that background, let's look at the basic requirements for perpendicular curb ramps. I've broken this down into some steps, and obviously you can do these in whatever order you'd like to do, but you'll see my steps are like 1, 2, 3. Again, just for review, this is a typical perpendicular curb ramp. Notice the ramp here is this bluish feature in the center. The darker gray would be the detectable warning surface. We have a level landing at the top. And so this area here is the pedestrian access route. The area from the back of the curb to the back of the sidewalk is available. It's a hard surface for pedestrians to walk on. And so that's the pedestrian circulation area, is from the back of curb to the back of sidewalk. But the accessible part of it, the PAR, is this part back here. Notice because the ramp lies within a pedestrian circulation path, we need to have flares. And notice there should be a flush transition at the base of the ramp. In terms of measurements, I've talked about how the maximum cross slope is 2%. That is a maximum. There's no allowance for construction tolerance. So if your designers or if your concrete crews say the best I can do is plus or minus 0.5%, I recommend designing these for 1.5% so that when they're built, they won't exceed 2%. So that's why you see my suggested landing running slope and landing cross slope are 1.5%. Similarly, down here in the last bullet, my suggested ramp running slope or grade is 7.5%. The maximum allowable is 8.33% or 1 in 12. But designing for 7.5 should provide that when it's actually constructed, it shouldn't exceed 8.33%. The landing length should match the curb ramp width, and the landing width should match the sidewalk width. Mentioned before, the flare slope should be 10% or less. There should be a 2-foot in the direction of pedestrian travel, detectable warning surface or truncated domes, the full width of the ramp, wherever the curb is missing. The sidewalk cross slope, 2% or less. The counter gutter slope, 5% or less. And then ramp cross slope, which of course would be the slope at right angles to the direction of the ramp. These criteria presented here are for new construction. And you can see the ramp cross slope, which is also the crosswalk cross slope, is a function of the traffic control on that particular road or street. So if the roadway is stop or yield controlled, the maximum ramp cross slope, maximum crosswalk cross slope is 2%. If the roadway is signalized or uncontrolled, 5%. And for a mid-block crossing, the cross slope of the ramp and the crosswalk can match the street grade. So where do you measure? Here's the various steps. As I said, you can do it in any order, but these are the order that I've indicated, at least for example purposes here. So step one would be to check the landing cross slope. And to do that, place the level on the landing perpendicular to the road. Step two is to check the landing running slope, and there place the level on the landing parallel to the road. Step three would be to check the ramp running slope, and to do that, place the level on the left, right, and center of the ramp perpendicular to the road, as you see here. Step four is to check the ramp cross slope. I'd place the level on the front and back of the ramp parallel to the roadway, as you see here. My step five would be to check the left flare slope. So place the level on the left flare at the back of curb parallel to the road, parallel to the curb. Step six would be to check the right flare slope. Again, place the level on the right flare at the back of curb parallel to the road. Step seven is to check the running slopes in the gutter area. The curb running slope and the ramp running slope should be the same. Here we're measuring the curb running slope. Obviously, you don't need 6 levels like you see here, but one can do it, of course. But I'm just showing that you probably should take the average grade of the curb surface at several locations across the ramp. Place the level on top of the curb perpendicular of curb. And I think you can see it might be tough to be able to use a 2-foot level here, 24-inch level. So this is a case where the 6-inch level comes in handy. And then to measure the counter slope, that's the grade of the street or the gutter pan perpendicular to the street or gutter pan. Again, might be a good location for the 6-inch level if the 2-foot level doesn't fit. Some key curb ramp considerations. Be sure you design the ramp for each location and not simply refer to say a typical or standard drawing, because most ramps don't look like the cookie cutter ramps shown here or oftentimes shown in textbooks and things. You really have to design each ramp for the particular location situated in, because there's of course differences in terrain, drainage, right-of-way, buildings and structures and so forth. And so it's hard to fit a typical design into every location. Make sure your grade brakes are perpendicular to the direction of travel so that both wheels of the wheelchair navigate the grade brake at the same time. Notice here, I know this is a cartoon, but notice here, this is what I'd call a skewed ramp. It's not appropriate to have a skewed ramp, but notice the one small front wheel of the chair is already in the gutter pan or in the street. The other one now has not yet reached the street, but if you look closely, it's off the ground. And that is something we definitely want to avoid. Anytime one or more wheels of a manual wheelchair leaves the ground, the stability of that chair is jeopardized. It could tip over or flip over. And so we want to make sure our designs are such that all 4 wheels of a manual wheelchair stay on the ground at all times. I think I've mentioned this before. I'll probably mention it again, but to me it's very important, and that is the wheelchairs and the gutter pans. Small vertical discontinuities that may not seem like much to us able-bodied pedestrians can pose real challenges to those using wheelchairs and other assistive devices. So we don't want to have them at the transition from the ramp to the street crossing. And this is staged. I staged this for the purpose of the image, but notice this wheelchair was proceeding from the street to the ramp. And so probably somebody in the chair is going to be kind of accelerating to try to build up some speed to get up that ramp. But then the small front wheels of that chair have struck the lip here, and you can see they go sideways and the chair will come to an abrupt stop. And it does happen, sadly, that people are actually catapulted out of the chair onto the pavement and can sustain serious injury. So having that flush transition from the curb ramp to the street is especially important. Also, if a crossing is prohibited, it needs to be closed off to all pedestrians, and there's a couple ways to do that. One way not to do it is to just have a sign that says sidewalk closed or no pedestrians beyond this point. The problem with that is that those signs don't communicate with the visually impaired. And so you should have the sign, I think, but you also need some sort of railing or barricade that's detectable with the cane, like you see in this left image. Another way to do it is to have a change in surface, like this grass here lets a visually impaired pedestrian, say using the cane, and say they're going north here toward the top of the image, they can detect that cane, that grass from the sidewalk, from the concrete with their cane, and that lets them know that this pedestrian path doesn't proceed any farther here to the north. They have to either turn left or turn right. Mentioned detectable warning surfaces. There is a requirement that they contrast visually with the street or sidewalk. That's so the low vision pedestrian can see them. Remember, they rely on color contrast. They can't see detail, but they can see color contrast. Something we've learned through experience is probably avoid using black detectable warning surfaces. Obviously, as you see on the left here, they provide good contrast between a light concrete background. But the issue, which we learned through experience, is that guide dogs and actually individuals with certain low vision conditions perceive this black pad here as a hole in the sidewalk and will actually walk around it. So to wrap up, let's look at Ron's top 10 curb ramp mistakes. These are not in any particular order. This is not like, say, the football rankings where 1, 2, 3 order is critical. These are just things that I see or that others have advised me they see as some of the curb ramp mistakes that are commonly made. One, and here we go again, I've mentioned this already a couple of times, the ramp is not flush with the gutter pan. There's that lip that can catch the small front wheels of the wheelchair. And the person in the chair may have to pop a wheelie, if you will, to be able to get up on the sidewalk. And not everybody has the upper body strength to be able to do that. The one on the left here to me is particularly sad because that's looks like well over an inch, maybe almost 2-inch lip there, which is maybe virtually impossible for someone in a chair to be able to negotiate that lip. I suspect maybe or hope maybe they're going to resurface the street and add an inch or two of asphalt. But right now, while they're waiting for that paving project, this, I would argue, is an inaccessible curb ramp. The other problem is the gutter pan is not flush with the crosswalk. So here the curb is actually to the left, or the curb ramp, which you can't see. This is the gutter pan, and it looks like the street has been resurfaced, but there's a lip of asphalt here, nearly vertical, that exceeds 1/4 inch. And so that becomes a barrier or obstacle to the mobility impaired. So we need to pay attention to that kind of that joint or that seam, that interface as well. And then we have obstructions. There's, of course, going to be obstructions in the built environment. Our obligation is to make the facility accessible to the maximum extent practicable. But in my opinion, it should also be safe And the location on the right, I would argue, is not safe for the visually impaired. This guy wire here is what's called a protruding object, meaning it's by virtue of its height, it's high enough that someone can run into it, but it's so high that someone with the cane can't detect it. In other words, they'll run into it before they detect it. And I've had people tell me, well, they put yellow here so it's visible, which is good for those sighted people. But remember, not everybody can see. So this is here on the right is a serious safety issue for the visually impaired. No level turning space. Needs to be a level turning space. This static image does not convey the degree of effort that's required to make this maneuver, to try to move a manual wheelchair up a ramp and at the same time turn it. Takes considerable effort. And again, not everybody can do that. The reason this individual is wearing gloves is not because of cold weather, but because of the wear and tear. Just this what seems like a simple maneuver does to the palms of one's hand. So I mentioned earlier, curb ramps are the basic element of accessibility. To me, the key element of a curb ramp is to make sure we have level turning spaces at the top of our ramps. Detectable warning surface not cast in place. I don't mean to imply that they all have to be cast in place. They can be surface applied, but make sure there's no lips. I would argue the workmanship here is pretty bad. That notice there's a pretty good lip here, exceeds again a 1/4 inch, and that's a tripping hazard for all pedestrians. It could be a mobility issue, accessibility issue for those using assistive devices. And then also notice the detectable warning surface is not the full width of the ramp. Everywhere the curb is missing at a street crossing, and this does not comply with that. Back here, we emphasize that again. Here's some other examples of the detectable warning surface not being the full width of the ramp. Notice here on the left, it's possible that a low vision pedestrian who's walking near the edge of the pavement here could walk out into the street without even realizing it, because they may not come into contact with the detectable warning surface. Their foot may not come down on that pad, if you will. And then the one on the right, this is actually not too far from where I am this afternoon speaking to you here in Morgantown, West Virginia. Relatively new project, but to me, the inspector dropped the ball here. Notice this gap in the detectable warning surfaces, but there's no curb. And so someone using a cane or a low vision pedestrian could inadvertently walk into the street without realizing it, because there's a possibility of them crossing this area here without encountering the detectable warning surface. So it's critical that the curb ramp extend the full width of where the curb is missing, or as I say at the bottom of the slide, if you have a shared use path or multi-use trail or something like that, the detectable warning surface must be the full width of that path or trail. Another mistake that's often made is the ramp does not fit within the crosswalk. As you see here, this is a single diagonal ramp, which we should not be building any more new single diagonal ramps. I realize there's a lot of them out there, but we should not be building any more new single diagonal ramps. And this is one of the reasons why. Notice, to get from the crosswalk into that ramp, this individual has to leave the protection of the crosswalk. And if you look closely, notice they have their back to traffic, which is very disconcerting. So from a safety standpoint, this is not a good situation. That individual cannot keep an eye on the vehicles, the motor vehicles that are approaching him. Also, another mistake is no level area for the push button at a signalized intersection. We haven't really talked about signalized intersections, but you see a couple examples of push buttons here. And one thing we also haven't talked about is how a manual wheelchair is braked, B-R-A-K-E-D, braked or stopped. The way a manual chair is braked or stopped is by the person in the chair holds on to the wheels with both hands. And so if they're holding on to the wheels with both hands, they don't have a free hand to activate a push button. So notice here, this push button, which we see the side of, is located next to a level turning space. So a wheelchair on that turning space shouldn't have to, user won't have to have both hands on the wheels. So that's good. But notice this push button is on the ramp grade itself, and the user is probably going to have to use two hands just to prevent the chair from running toward the street. And so this is not an appropriate location for a push button. This push button actually should be close to the level turning space. Another mistake, no receiving ramp. There's several mistakes here. Notice there's no detectable warning surface here either. But notice on the other side of the street, there is no way for this individual to get back up onto the sidewalk because, as I say, there's no receiving ramp. They're going to have to probably go in the street for some distance to find a driveway or some other location where they can get up onto the sidewalk. And that presents some safety issues. So there should be two ramps at every location, one to take people into the street and the other to receive them, to get them back up onto the sidewalk. And then this is the 10th and final mistake, is misuse of return curbs. Notice here on the left, this sidewalk, the whole width, what's that, maybe 10 feet, 8 or 10 feet, is a pedestrian circulation area, pedestrian circulation path. So we do not want these vertical edges or lips or steps here because these can trip all pedestrians, even able-bodied pedestrians. To me, I'm not sure why they didn't just ramp down this entire end of the sidewalk here with a detectable warning surface across the entire width of the sidewalk. Would have been a preferable design, in my opinion. And then here on the right, we see a curb on the left side of this sidewalk. Not sure, maybe that's for drainage. I'm not sure why. But notice when I took this photo in the morning, that curb is pretty visible because of the shadowing here. But think about later on in the afternoon when there may not be any shadows, the sun is higher in the sky. All this concrete, especially for someone with low vision, going to blend together and they won't be able to see that there is a raised curb there. So this is a safety issue, I think, again, for all pedestrians. So we need to keep that in mind when we're using return curbs. So that's all I have. Apologize for having to rush through that, but at least we got it covered. I'd be glad to answer any questions or address any concerns anybody has. Heather, did we get any questions come in?
I am checking the chat. We have one that says, what are the guidance for the transition from ramp to street? But that was in the beginning. Rob, did you get the answer to that?
Yes, kind of. More specifically, where the asphalt from the street comes down to where the gutter is there a guidance as to what that percentage of slope can be? I've just seen some work around the state where the transition is quite steep.
Yeah, let me back up. I know this is not maybe the best example, but you're talking about this area here where my cursor is, right? Where the street comes down to the bottom of the ramp.
Yes, sir.
Yeah, and this is pretty darn steep here. I don't think this complies with the requirements. What ProAg says is that, and let me back up. may be giving you more than you want, but hopefully I'll answer your question. ProAg says where, a sidewalk is adjacent to a street or serves a street is another way of saying it, the sidewalk can be the same gradient as the street, regardless of how steep it is. We have some, I'm here in West Virginia, we're not as mountainous as Colorado, but we have a lot of hills, rolling hills here, so we have some steep terrain. And here where I am in Morgantown, one of our main sidewalks is about 26%. Main streets is 26% is the gradient of the street. And there's sidewalks adjacent to that street. Well, those sidewalks at 26% are acceptable in that case because they follow the street. But ProAg also says where a sidewalk doesn't follow the street, the maximum gradient is 5%. And that also applies for crosswalks at street crossings. So for example, this is not, it doesn't appear to be marked as a crosswalk, but I think we'd all agree, given its location here at the corner, this crossing location is a legal crosswalk by the Motor Vehicle Code, even though it's not marked. And so ProAg says the maximum grade here of this crosswalk, which becomes then the cross slope of the street, is 5%. So actually the maximum gradient here would be 5%. As I said, I think this greatly exceeds that. This looks pretty darn steep, but that's a long answer to your question. Hopefully I answered that, but the maximum gradient here would be 5%.
Okay. That answered my question, and unfortunately some of the work that I've seen makes that slope look quite easy and gentle. So
yeah, I know what you mean. Yeah, we just earlier in April, we did a walkabout here in LTAP for one of our historic West Virginia communities, and they had been resurfacing the street for years and years without any milling or anything. And yeah, there the cross slope we measured was 13%. So that's that's not, there's not an easy fix for that. So they're going to have to think about what to do to get that down to 5%.
Sounds good. Thank you.
You're welcome. Good question.
We did have a request for a copy of this presentation. I did in the chat post where the recording will be posted. Give me a day or two to get that posted, but it'll be available on the link provided. If you'd still like a digital copy of the presentation, I think Ron said he'd be willing to share that if you wanted to drop your email in the chat.
Yeah, email me or put your email in the chat, or I can get it to Heather, whatever's the easiest. But yeah, I'll be glad to share a PDF of this presentation.
Okay, so I'm gonna butcher your name. I would say Robespierre Howard in Alaska has a curb ramp and would like an opinion. Ron, I will send you also the email address so that you can send the presentation. Okay. And Rob wants it too. Any other questions? Okay, well, we'll go ahead and give you 8 minutes back to your afternoon or evening. Thanks so much, Ron, for coming. Always a pleasure, and thanks for sharing your intel.
Well, thank you, everybody, and thanks for the questions. And hopefully this was helpful. And enjoy the rest of your day. Thanks.
All righty. Have a good one, everyone.
Thank you.